All right, for question 58, it says for each equation, write the value or values of the variable that make the denominator 0 and then solve the equation. So we're looking for the restricted values. Oops. I'm just gonna put RV, restricted values. Okay, and how do we find the values that make the denominator 0? Well, you just said the denominator is all equal to 0. So we're going to set x minus 4 equal to 0. And when we solve, we get x equals 4. And then we're going to set x plus 5 equal to 0. And when we solve that, we get x equals negative 5. And then we're going to set x squared plus x minus 20 equal to 0. And this one you're going to need to factor. So when we factor it, it factors to x plus 5 times x minus 4. And when you set each of these equal to 0, you'll find that you get the same things that we already have up there, where x cannot be negative 5 and x cannot be 4. So here's all the restricted values that we have. We have 4, negative 5, and then the same two values again. Okay, so these are all the restricted values. We've set every denominator equal to 0. And so once you solve the equation, as long as you don't get one of those numbers, 4 or negative 5, then you're good to go. So how do we begin to solve this? Well, we need to really get rid of the denominators. So if we can find the least common denominator and multiply everything by that number or that quantity, then we can essentially get rid of these denominators. So I'm going to multiply, well, let's see, the least common denominator here is, well, let's see, let me rewrite. I think I'm going to get rid of that calculator for now. I'm going to zoom in just a bit more. And I'm going to write this as x over x minus 4 minus, actually, yeah, that's fine. We'll leave that there. X plus 5. And then I'm going to put this over its factored denominator, which is now x plus 5. Oh, shoot. X plus 5 times x minus 4. There we go. Now it's a little bit easier to see the LCD, and the LCD is just the x plus 5 times x minus 4. So I'm going to write that just over here. Here. LCD is x plus 5 times x minus 4. Okay, so if I multiply all the things by the LCD, what's going to happen is all the denominators are going to cancel out, right? So I'm going to, don't have a ton of space here, but I guess I'm going to go ahead and put x plus 5 times x minus 4. Sorry, this is going to be a lot of writing over x minus 4 here. And then we have minus x plus 5 times x minus 4 times 4 over x plus 5 equals, and of course, whatever you do to one side of the equal sign, you have to do to the other side of the equal sign. So x plus 5 times x minus 4 times the 36 over x plus 5 times x minus 4. Okay, now here's the best part, of course, that you get to cancel things, right? Like this cancels out, and then this cancels out. And when we say they cancel, what we're really saying is they divide to equal 1. So what we have left now is x times x plus 5 minus 4 times x minus 4 equals 36. Okay, so now let's distribute and combine like terms and all that good stuff. Man, I did not leave enough space for this problem. This is going to be x squared plus 5x minus 4x plus 16 equals 36. So when I combine my like terms here, I get x squared plus x plus 16 equals 36. But now I need to subtract the 36 over. So x squared plus x minus 20 equals 0. And now I have a quadratic equation that needs to be solved. So I'm going to bring this up here. Put x squared plus x minus 20 equals 0. And when I factor this, I get x plus 5, x minus 4 equals 0. So let's see. If I get x equals negative 5 and x equals 4, well, I think this might be a problem for us, right? In that both of these are not going to work. So you're noticing probably that I have some restricted values here, right? Remember here how I just said that these are all restrictions over here. These are all the restrictions, right? Well, I see that that's a problem and that's a problem, right? So, well, this problem has no solution then, I guess. No solution. Man, all that work for that, right? Now, that's just one way to approach this problem. Another method is to, write both sides as a single fraction. So you could multiply the top fraction or the first fraction here by, you can multiply this by x plus 5 over x plus 5. And then you can multiply this by x minus 4 and this x minus 4. And then you could, combine the numerator parts. And then you would have, the same denominator on both sides. And then, you'd set your numerators equal. But just pretty much what we did. So, that's one option, to approach the problem. Okay, so let's look at letter B. So same thing, we need to write our restricted values over here. So I'm going to take x squared plus x, set that equal to 0. And I'm going to factor out an x and get x plus 1. So when I set these equal to 0, I get 0 and negative 1. So these are two restricted values there. And then I need to set also x equal to 0, which, of course, is already solved. So there you go. So these are our restricted values for this problem over here, okay? So as long as our answers aren't either one of those, 0 or negative 1, we're good to go. So my LCD here, if I write these as in their factored form, this is x plus 1 here, equals 1 over x minus 5. My LCD is going to be x times x plus 1. Okay, so once they're all in their factored form, you can see, well, I could write them, if I multiplied, this one here by x plus 1 over x plus 1, and then I could multiply this by x, times x plus 1. That would be the smallest denominator we could get. So what I'm going to do is I'm going to multiply everything by the least common denominator. So 1 over x times x plus 1 equals, and then same thing on this side, x times x plus 1. And if you keep it in the factored form, then it makes it easier to cancel things. So that's why I always put these in the factored forms, because then I can cancel stuff nicely. So now here I see that my x's are going to cancel and my x plus 1s. That's cool. X's are going to cancel there, but that's pretty much it, right? Those are all the denominators. So what do we have left? We have 1 equals 1 times x plus 1 minus 5 times x plus 1. Okay, so 1 equals, well, this is just x plus 1. And then when I distribute, this is 5x, right? So I get negative 5x squared minus 5x. All right. This is horrible. This is a terrible problem. Okay. So let's get everything on one side. I would like to, let's start by combine like terms. I get negative 5x squared. This is minus 4x plus 1. And I'm going to move everything to the left side because I need my x squared term to be positive. So I'm going to add 5x squared, add 4x, and subtract 1, all to the other side. Although you can do it in a different way. You could just subtract the 1 over and then divide everything by -1, although that's probably easier. Let me do that instead. Okay, so subtract 1 on both sides. So I get -5x squared minus 4x. Well, these are both 0, right? This is 0 and this is 0. So equals 0. Okay. Let me write it this way. I'm sorry, guys. Try not to confuse anybody. Okay, so brought the 0 down on the left, and then I brought this. This ended up being 0 on the right. So now I need to get these to be positive. So if I divide everything by -1, then I have positive 5x squared plus 4x equals 0. Okay, well now, actually this problem is not as bad as I thought it was going to be. I can factor out a greatest common factor of x, which leaves me with 5x plus 4. And now if I just set each of these equal to 0, then I get, let's see, 5x equals -4 and x equals -4 over 5. So now I have to check to see if I have any restricted values. And it turns out I do. This one here, that's a problem. However, the other one's all good, right? This one, no problem here. X can be -4/5. So I have one solution, right? Let me not do it that way. I'll just write it over here. X equals... So there's only one solution. The other one is what we call extraneous and is not a solution because it creates 0 in the denominator. Okay, last one. So let's look at our restricted values for this problem here. Okay, so set x plus 1 equal to 0, and I get x equals -1. Set x minus 1 equals 0, and I get x equals 1. And then if I set x squared minus 1 equal to 0, well, I would factor that difference of squares, right? So x plus 1 equals 0, x minus 1 equals 0. So x equals -1 and x equals 1. Okay, so we've got -1, 1, -1, and 1. These are all the restricted values there. All right, so let me box that all up there. Okay, so now we need to figure out what is our least common denominator. So the LCD for this, if you look at all the factored denominators, this is 2 over x plus 1. This is 1 over x minus 1. And this is 2x over x plus 1, x minus 1. So it looks like the factored form there, x plus 1, x minus 1 would be our LCD. So we're going to multiply all the things by that. So x plus 1 times x minus 1 times 2 over x plus 1 minus, and then, okay, x plus 1, x minus 1 times 1 over x minus 1 equals, and then we're going to put x plus 1, x minus 1 times 2x over x plus 1, x minus 1. All right, there we go. Super long, but it's done. So x plus 1's cancel here, x minus 1's here, and of course both of them over here. So what do we have left? 2 times x minus 1 minus 1 times x plus 1 equals 2x. So 2x minus 2 minus x minus 1, make sure you distribute everything, right? Equals 2x. So 2x minus x is going to be just x, and then minus 3 equals 2x, right? So if I combine my like terms, I get 2x and -x, and then -2 and -1, right? So that's just 1x and then minus 3. All right, and then I'm going to subtract x over. So we get -3 equals 2x minus 1x. It's just x. So I get x equals -3, and now I check, and it turns out it is not a restricted value, so that is my solution. All right.